Welcome to the IT Learning Hub webinar course implementing the new 6th edition of the Highway Capacity Manual. This webinar is webinar 1 of 8, titled What's New in HCM 6 and What It Means for You. The Highway Capacity Manual 6th edition incorporates the results of millions of dollars of national, peer-reviewed research that has occurred since the publication of the HCM 2010. This edition of the HCM introduces a number of new capabilities, including travel time reliability forecasting, alternative intersections analysis, managed lane analysis, and work zone analysis. It also updates a number of existing methodologies, including those for freeway facilities and roundabouts, recognizing that most users of the HCM implement its methods through software. This edition of the HCM highlights information that users need to know when applying the manual through software, such as input data needs and potential sources for specific performance measures, recommended default values, information on the sensitivity of results to specific inputs, and guidance on interpreting analysis results. Finally, the HCM's expanded name, Highway Capacity Manual 6th Edition, a guide for multimodal mobility analysis, is intended to highlight the HCM's ability to analyze the operation of non-auto modes and to highlight the range of roadway performance measures that HCM provides beyond traditional level of service. Today's webinar, the first webinar in the series, will provide a high-level overview of the key changes to the HCM, including new and updated analysis capabilities, an extended set of online resources accompanying the HCM, and changes to how information is presented, all to better support the way today's users apply the manual. This webinar will also highlight information that will be explored in depth in subsequent webinars in the series. The learning objectives for today's webinar: understand the need for a new HCM edition, understand why the HCM is still relevant to planning and engineering practitioners, learn at a high level about the major changes and additions to HCM, learn about the resources that help support the HCM. Okay, and now I would like to introduce today's presenters. We have Lily Eleftheriou. Dr. Eleftheriou is the director of the UF Transportation Institute and the Kissinger Campo Professor of Civil Engineering at the University of Florida. Her research focus is traffic operations, traffic flow theory, and simulation. She is the past chair of the TRB Highway Capacity and Quality of Service Committee. Paul Reyes is the principal engineer with Kittleson & Associates. He grew up in California, lived in Portland, Oregon for 15 years, and is now based in Svendborg, Denmark. He is a lead author of a number of guidebooks published by NCHRP and NCRP, including Guides on Transit Performance Measurement, Transit Supportive Roadway Strategies, and Pedestrian and Bicycle Volume Counting. He served as the research team's technical editor for both HCM 2010 and the HCM 6th edition. He is a member of the TRB Committee on Highway Capacity and Quality of Service and chairs the TRB Committee on Transit Capacity and Quality of Service. Bastian Schroeder is a principal engineer with Kittleson and Associates as well, and manages the company's Wilmington, North Carolina office. He served as principal investigator, or co-PI, on over 25 funded projects for sponsors including FHWA, NCHRP, SHRP2, ITE, North Carolina DOT, and others. Recently, he oversaw the development of all freeway chapters in the 6th edition of the Highway Capacity Manual, expected in 2016. Dr. Schroeder has authored or co-authored over 70 peer-reviewed journal articles and conference proceedings. He is a member of the TRB Committee on Highway Capacity and Quality of Service, the TRB Committee on Roundabouts, the TRB Simulation Systems Manual Task Force, and he chairs the Simulation and Capacity Model Users Group for North Carolina section of ITE. Okay, so now I will hand the floor over to Lily. Lily, I will pull up your slides here in one moment.
Okay, thank you, Courtney. Good afternoon, everyone. I hope you can hear me okay. As Courtney said, I've served as the past chair for the Highway Capacity Manual as it was being developed for this 6th edition. The HCM has been around for more than 60 years, and over that time it has changed very significantly. If you think about the earlier versions, they weren't even considering congestion. And so with this version, again, the HCM is following the trends in the profession and society, and with this new edition, it addresses some of the very timely topics such as advanced traffic management and travel time reliability and multimodal analysis. The HCM's greatest value is that it represents the consensus of numerous transportation professionals from industry, academia, and the private sector, which are represented on the Highway Capacity and Quality of Service Committee, of which both Paul and Bastian are members and have been members for a while. The version that just has been published was reviewed by roughly 200 professionals, including many ITE members around the country. The production team received approximately 3,300 comments on various draft versions of the chapter. So the product that you see here is the result of a lengthy process and significant review and consensus building. The HCM strength is in providing methods for estimating a large set of very useful performance measures to evaluate mobility. Now, to put things in context, if you look at the slide, there are 4 dimensions of mobility. The HCM focuses on the capacity estimation and the quality of travel, or what you think of as level of service. It uses the quantity of travel, the demand, the VC ratio, and so on, as an input, and it really doesn't address accessibility. So from a big picture perspective, this is where the HCM fits. It can estimate capacity and quality of service. However, keep in mind that a good performance measurement framework must look at all dimensions or multiple dimensions. For example, looking just at the quantity of travel is not enough to evaluate a system. So those are the main points that I wanted to make, and with that in mind, the HCM has some significant changes that Paul and Bastian will go over, and I just wanted once again to highlight the change in the title, which is now HCM, a guide for multimodal mobility analysis, which reflects the significant updates in multimodal analysis and in expanding the mobility performance framework for the HCM. So with that, I'm going to turn it over to Paul. Thank you.
Okay, thank you, Lily. The organization of today's webinar matches the learning objectives that Courtney presented earlier. We'll present why an updated highway capacity manual was needed, show you where to go to find information in the 6th edition, provide an overview of the HCM's new analysis capabilities, and wrap up with a summary of what we've covered. We'll start by exploring the need for an updated HCM and by reminding everyone of the purpose of the HCM. The Highway Capacity Manual is the leading U.S. reference document for capacity and quality of service concepts, performance measures, and methodologies for the multimodal operation of highway and street facilities. The first Highway Capacity Manual was published in 1950, was 160 pages long, and focused on capacity. Since that time, new editions of the HCM have been published every 10 to 20 years. By 1985, all of the travel modes currently addressed in the HCM were included, at least to a limited extent. Beginning in 1985, a major emphasis of each new edition has been presenting the results of new research on highway capacity and quality of service. And as a reminder, quality of service expresses roadway performance from the user point of view. While all of this research has greatly expanded the HCM's capabilities, it has also meant that the HCM has grown significantly larger over the years, and a significant challenge with more recent editions has been determining how to present all of the information in a way that is useful to the HCM's wide range of users. One solution has been to move some information out of the printed manual and into online chapters. There are a number of reasons why new research is conducted and subsequently integrated into the Highway Capacity Manual. Driver behavior has changed over time, as have the types and capabilities of vehicles on the roadways. Technology has advanced. Traffic signals have evolved from pre-timed operation to actuated operation to adaptive systems. Roadway features such as modern roundabouts and managed lanes have become widely adopted. As it has become harder and harder to add roadway capacity, the need to effectively manage existing capacity has become increasingly important, as has the need for measuring the effectiveness of techniques designed to manage capacity. Looking ahead, advances in connected and autonomous vehicles will undoubtedly impact roadway operations. Several $1 million in new research has been performed since HCM 2010 was published. Some of these projects introduce new capabilities to the HCM, analyzing managed lane and work zone operations, measuring and predicting travel time reliability, analyzing alternative intersection forms, and evaluating roadways incorporating a series of roundabouts. Some projects update previous research to account for driver behavior and technological changes, truck analysis, roundabouts, and active traffic and demand management, or ATDM. Finally, some projects have focused on enhancing how all of this new and existing information can be effectively communicated to HCM users. Later in the presentation, we will go into more detail about how this research has been incorporated into the HCM. This wealth of national research is the strength of the HCM. The manual's methods have been researched and tested on a national scale, and the research reports supporting most major HCM methods are available as part of the online Volume 4. At the same time, recognizing that local conditions often vary from national averages, the HCM provides guidance on calibrating its methods to local conditions. The creation of Online Volume 4 as part of HCM 2010 allowed the HCM to be updated more quickly after research was completed, compared to the typical minimum 10-year wait for a new edition. 4 such chapters were released online in 2014. Each chapter was standalone and could not be used in conjunction with other new material, for example, to evaluate the reliability of managed lanes. In order for research to become implemented, it needs to be usable by practitioners. These days, this often means that methods need to be implemented in software. In order for software to be developed, the new methods need to be integrated with existing material and explained in sufficient detail that software developers can accurately replicate the method. At the same time, the need exists to explain the methods clearly to end users. As a result, a new edition of the HCM was required. In addition to the need to integrate new content into the HCM, the need for a title more descriptive of the HCM's contents was becoming apparent. The HCM's content has evolved to keep pace with the analysis needs of transportation professionals, but the basic title has stayed the same since 1950. Transportation professionals and decision makers have not always been aware of the features that have been added with each new edition. Roadway transportation practice has evolved from a focus on constructing the interstate highway system from the 1950s to the 1970s to managing a complex transportation system that serves a variety of users and travel modes. Providing mobility for people and goods is the most essential function of the transportation system. As Lily explained earlier, mobility consists of the 4 dimensions shown here. Of these, the HCM has been the leading reference for evaluating capacity and quality of travel, while quantity of travel is a key input to HCM methods. Thus, a guide for multimodal mobility analysis captures the HCM's ability to quantify roadway performance across multiple dimensions and travel modes. Previous HCM editions have had a year in the title, although they've also been referred to as an edition somewhere inside. It's become increasingly impractical to wait 10 to 15 years for a critical mass of new research to be completed to issue a new HCM. The online Volume 4 introduced with the HCM 2010 facilitates issuing new and updated chapters. In the HCM 6th edition, each chapter will have its own version number, starting with 6.0, which will be updated as interpretations and errata are released and as new research is incorporated. This approach will allow the HCM to continue to present state-of-the-art methods while allowing analysts to tie their analysis to a specific version of a methodology. Most practitioners today conduct traffic operations analysis via software. For example, there are software packages that implement HCM methods, software packages that perform macroscopic traffic operations analysis using non-HCM methods, and microscopic simulation tools that can analyze individual vehicle movements and create attractive visualizations. Given the widespread use of software, it's fair to ask whether there is still a need for a thick highway capacity manual providing step-by-step analysis procedures. Practitioners work with different analysis tools and different levels of input data precision for different types of analysis. The HCM supports a wide range of applications, ranging from planning studies, where study areas may be large and relatively little data are available for any given facility, to detailed operations analysis of a single facility or intersection where conditions are known precisely. In addition, the 6th edition provides guidance on how to use the HCM, its applications guides, and its other resources in conjunction with other traffic analysis tools. In addition, the HCM can do things that other tools cannot, such as forecasting travel time reliability. HCM methods are also well-researched and well-documented, providing transparency and confidence in the results, while preserving an analyst's ability to fine-tune methods to match local conditions. Even though the majority of HCM users apply HCM methods through software, there is still a need for analysts to understand how a method works, even though they aren't performing step-by-step calculations. They need to know what inputs are required, how variations in those inputs may impact the results, the research basis underlying the method, the basic flow of calculations, the range of likely results, and resources to turn to in case of questions. In addition, a subset of users, including analysts who want to explore the reason behind a particular result, still requires in-depth information about each method. Next, we'll look at where you can go to find information in the 6th edition. The HCM is divided into 4 volumes, 3 printed and 1 online. Volume 1 houses material on concepts that all HCM users should be familiar with before applying the HCM. Volume 2 describes the methodologies for freeways and highways, while Volume 3 describes the methodologies for urban streets and off-street pedestrian and bicycle facilities. Volume 4 provides additional resources that support the material in the printed HCM. We'll briefly go through the contents of each of these chapters, each of these volumes in the next few slides. Later in the webinar, we'll go over the important changes in the HCM. The HCM 2010 reorganized the manual to better serve its users. Core information essential to understanding an analysis method was provided in the printed chapters. Depending on the complexity of the method, this information could range from full step-by-step instructions to a high-level overview of a method's input and the flow of calculations. The online supplemental chapters provided calculation details for the more complex methods and other information primarily of interest to a subset of HCM users. For some methods requiring iterative calculations, computational engine code listings provided in the online technical reference library offered the greatest level of detail. The online library also provides access to many of the research reports that document the development of HCM methods. The HCM 6th edition continues the evolution of how HCM information is presented to better serve the needs of today's users. As will be described in a moment, methodological chapter outlines have been standardized. Summary tables are provided that list data requirements, potential data sources, suggested default values, and the sensitivity of results to particular inputs. Example results in many chapters allow analysts to check the reasonableness of their results. To make room for new content, example problems showing step-by-step calculations have been moved to the supplemental chapters in Volume 4. The Volume 2 and 3 methodological chapters follow the same outline. Each chapter begins with a short introduction describing the purpose of the chapter, the information found within it, and cross-references to related material in other chapters. General highway capacity and quality of service concepts are covered in Volume 1, but method-specific concepts, including level of service tables and other information, are provided in the individual chapter concept sections. The core motorized vehicle methodology, for example, two-lane highway analysis for motor vehicles, is presented next. This section includes descriptions of the method's strengths and limitations, circumstances when alternative tools might be considered, the method's required input data and potential sources for that data, and a description of the flow of calculations. If provided, extensions to the methodology, for example, passing lanes on two-lane highways, are discussed following the core methodology. Next, when available, mode-specific methodologies, for example, bicycle travel on two-lane highways, are provided in subsequent sections. Finally, an application section provides information about applying the chapter's method to planning and preliminary engineering, operations, and design analyses, often provides example results, and discusses the use of the method in conjunction with alternative tools when available. Each printed volume also provides an index to help users quickly locate material of interest. The summary data table accompanying each method is designed to provide a one-stop resource for determining a method's data needs. The table for two-lane highway motorized vehicle analysis is depicted here. The table identifies all required input data in their units, lists potential sources for these data, and identifies which inputs can be defaulted and which must be specified by the analyst. The majority of inputs can typically be defaulted, although for the most accurate results, it is preferable to supply specific values whenever these can be obtained. The table also indicates which default values have a particularly strong influence on the results, and therefore require the most care in applying. Bold type indicates that the result can change by 10 to 20% when the input, for example, free flow speed, is varied over its typical range of possible values. Bold italic type indicates that the result can change by more than 20% when an input is varied, for example, percent no passing zones, or passing lane length. Results are relatively insensitive to the choice of default value for other inputs. Any input shown as must be provided cannot be defaulted, and the results are typically highly sensitive to the values provided for these inputs. This table also demonstrates the HCM's flexibility. For a planning analysis of a two-lane highway, only 5 data items must be provided by the analyst, but for an operations analysis, the method is sensitive to 13 different input factors. Many Volume 2 and 3 chapters now provide example results to help analysts determine the reasonableness of the results they obtain from software, to highlight a method's sensitivity to particular inputs, and to highlight possible methodological quirks such as step function behavior. The example results are not intended to substitute for an actual analysis, as the results depend on the assumptions used for other inputs, and are therefore deliberately printed at a size large enough to indicate trends, but too small to pick out specific results. This graph from the two-lane highway chapter illustrates the sensitivity of percent time spent following, used to determine level of service on some types of two-lane highways, to analysis direction volume and the percentage of no passing zones. It can be seen that percent time spent following increases with both increasing volume and increasing no passing zones, and that the result is highly sensitive to the choice of percentage of no passing zones at most volumes. The graph also indicates generally the expected range of percent time spent following results for a given analysis direction volume. Example problems have been moved to the supplemental chapters in Online Volume 4. This was done for a variety of reasons, including making this material accessible to all, including students who don't yet own a copy of the Highway Capacity Manual. Now I'll briefly go over the chapter organization of the HCM, starting with Volume 1. Volume 1 presents concepts that all HCM users should be familiar with before applying the manual, either by hand or through software. The chapter structure of Volume 1 is the same as the HCM 2010. Chapter 36 in Online Volume 4 provides supplemental information that supports Volume 1. New information in this chapter includes guidance on measuring travel time reliability in the field and listings of reliability values for selected U.S. roadways. Chapter 37 provides concepts related to active traffic and demand management. HCM Volume 2 provides concepts, performance measures, and analysis methodologies specific to uninterrupted flow facilities, such as freeways. Chapter 11 on freeway reliability analysis is new. In addition, the HCM 2010 chapters on basic freeway segments and multi-lane highways have been merged into a single chapter, Chapter 12, as these roadways share many similar characteristics. Chapters 25 through 28 in Online Volume 4 provide material that supplements the Volume 2 chapters, including example problems. HCM Volume 3 provides concepts, performance measures, and analysis methodologies specific to interrupted flow facilities such as urban streets and the intersections found along them. Chapter 17, presenting methods for evaluating travel time reliability on urban streets and analyzing the effects of ATDM strategies, is new in the 6th edition. In addition, Chapter 23 has been expanded to cover alternative intersection and interchange types, such as diverging diamond interchanges and median U-turn intersections. Chapters 29 through 35 in Online Volume 4 provide supplemental information, including example problems. HCM Volume 4 is available online at hcmvolume4.org. It can be accessed by anyone, including those who don't have a personal copy of the printed HCM, but you do need to sign up for a free user account to get access. If you signed up for the HCM 2010 version of Volume 4 prior to September 2016, you can log into the 6th edition version of Volume 4 using the same username and password as before. One key function of HCM Volume 4 is to provide access to the supplemental chapters that provide additional details about HCM methodologies, field measurement techniques, example problems, and more. These can be found in the methodological details section of Online Volume 4. The Interpretations and Errata section of Volume 4 will house official interpretations, clarifications, and errata as needed. You can also use this tab to submit potential errata to the Highway Capacity Committee, but recognize that it takes time for volunteers to investigate your questions. For fastest feedback, we suggest posing questions in Volume 4's discussion forum first. Questions about software bugs should be directed to the vendor of the software package you're using. Neither the Transportation Research Board nor the Highway Capacity Committee endorse or provide support for any particular software package. The Technical Reference Library provides access to many of the research reports, papers, and websites referenced in the HCM, organized by chapter. Depending on the document, you can either download it directly or be taken to a website where you can download it. As we'll describe later in the webinar, computational engines are available for a few methods, and these can also be downloaded from this section of Volume 4. The Applications Guide section of Volume 4 provides access to two tools that demonstrate how the HCM can be applied to actual projects. The new Planning and Preliminary Engineering Applications Guide to the HCM, the subject of the next webinar, demonstrates how HCM concepts and methods can be simplified and incorporated into planning-level evaluations and into planning tools such as regional travel demand models. Support materials for the guide, including spreadsheets, are also available here. The HCM Applications Guidebook provides 5 case studies demonstrating how the HCM can be applied to projects as they evolve from concept to design to implementation, along with a 6th case study demonstrating the use of the HCM in conjunction with simulation. Other sections of Volume 4 include frequently asked questions and a user-to-user discussion forum. You can also sign up to be notified by email when new material of interest to you is posted on the site. Next, Bastian will review the HCM's new analysis capabilities.
Okay, thank you, Paul. In the last part of the webinar, we will go over a few highlights of the analysis capabilities and new functionalities that are in the HCM 6th edition. Many of you have signed up for the full series, the full 8-session webinar series, and in the following 7 sessions, we will go into additional details for all of these. To start with, the slides illustrates just some of the many methodological advantages of using the Highway Capacity Manual and some of the new features, and also illustrates the new title, A Guide for Multimodal Mobility Analysis, where the HCM is now capable to analyze a range of modes, including bicycle traffic, vehicular traffic, pedestrian traffic, as well as a range of different facility types. The top picture shows a concurrent managed lane facility. The top right photo shows a diverging diamond interchange, which is now fully integrated into the HCM, as are 3 other alternative intersection concepts, as I'll go over in a later slide. There's new methodologies for work zone analysis, both on freeways and urban streets, as well as on 2-lane highways. There's also new roundabout calibration factors, new capacity estimates for roundabouts, and new methods for evaluating roundabouts and corridors. So overall, the HCM is a truly multimodal analysis guidebook. Summarizing some of the highlights for uninterrupted flow facilities, these are the freeways, multi-lane highways, and 2-lane highways. There's a long list of really core changes and new functionality that have never been in the HCM before. Reliability analysis is clearly one that has driven the new release of the HCM 6th edition only 5 or 6 years after the HCM 2010 came out. But other functionality on work zone analysis, a new truck method, a brand new planning methodology that's in the planning preliminary Engineering Applications Guide, Managed Lane Methodology, ATDM, Active Traffic Management, and other functionality integrated in the methodology to make it more user-friendly, more consistent, and allow for calibration based on the numerous data sources that are now available to many agencies, either in the form of roadside sensors or probe-based speed and travel time data. The HCM now recognizes these sources explicitly and provides guidance, for example, for estimating capacity for key bottlenecks and how to calibrate them. Similarly, on the interrupted flow side, so these are any urban streets, arterial streets with either signalized intersections, stop signs, or roundabouts, a brand new reliability methodology, similar advancements on work zone, truck methodology, and planning methods, a brand new roundabout corridor method based on NCHRP 3100 and results from a federal highway research on estimating new roundabout capacity, as well as new guidance for the 4 most popular and most common alternative intersections forms that were emphasized by Federal Highway through the Everyday Counts program. Going through a few of the analysis in details now, reliability analysis and active traffic management clearly has been one of the key driving forces for releasing a new highway capacity manual this year. Traditionally, in the top left, the HCM, as well as many other analysis tools, including simulation, have evaluated the annual average performance. Based on a traffic count that was performed on one day that may have been factored out to reflect a different day, we estimated the annual travel time, the average delay, the average queue length based on certain conditions. But the reality is closer to maybe what's shown in the top right of the slide. That is, travel times vary from day to day, from month to month. They're subject to non-recurring sources of congestion. And frankly, those are the ones that the customers of the transportation systems, the drivers and pedestrians and cyclists, that's what they remember. So these outlier days is really what drives the experience. And up to this point, these outliers have been ignored in traditional analysis. The HCM is now able to explicitly consider these sources. Similarly, as agencies are looking for improvement capabilities, we may, in a lot of ways, we have exhausted the ability for capital improvements, traditional widening projects, construction of new facilities, and so maybe cities, metropolitan areas, and agencies are turning to active traffic management strategies that can include hard shoulder running, that can include ramp metering, variable speed limit, dynamic lane control strategies that are really geared at increasing the reliability. Some of these improvements may have a small effect on the average travel time, as is shown in the bottom left, but may have a very large or significant impact on the reliability of travel. And therefore, to really evaluate and quantify the true benefit of these strategies, we really need to start by considering the reliability context to then be able to quantify the net improvement of these ATDM strategies on whole year performance, not just on the average day. With that, through the methods developed through the SHARP2 program and Project L08, the HCM has a methodology to consider traffic demand variability, that is time of day, day of week variability, the effect of incidents, which includes crashes, but also just broken down vehicles or debris in the road, other non-crash incidents, the impacts of weather conditions, the impact of work zones, and the effect of special events that can be football games or state fairs or other events that really change the average travel patterns and result in more reliability or more variability in travel. The HCM methodology already can evaluate the impacts of multiple study periods across multiple segments. And that is something that is not clear to maybe many users, even of the HCM 2010, that are used to maybe a traditional peak 15-minute analysis, which is signified by the highlighted cell, where the HCM traditionally focused on one 15-minute period of one segment along a longer facility, such as one merge area or one weaving area on a freeway. Even in the HCM 2010, the freeway facility methods, for example, were able to quantify the performance over multiple segments, as would be done in some common traffic analysis tools, but also across multiple time periods, as is typical to do in simulation, to really look at the performance of congestion growing and dissipating as is signified by the speed contours in the chart to evaluate their performance both over time and space. What's new in the HCM 6th edition is that we can now replicate that analysis along the fourth dimension, the reliability dimension, which changes different inputs from one day to the next, and therefore essentially batch processes this extended time space domain 250 times, for example, to represent every working day in the year. This ability to replicate an analysis very quickly is really a key advantage here of the HCM methodology over, for example, a microsimulation analysis that may take several minutes or even hours to execute, and therefore would be cost and time prohibitive to execute 250 times. The HCM calculations remain virtually instantaneous, and even the 250 scenario reliability analysis is done in a matter of a few seconds. As a result of the repeated application with varying inputs, different demand and incident scenarios, weather scenarios, the HCM can directly generate the travel time distribution as it's replicated here, and any of the performance measures that an agency may be interested in, or any of the performance measures that will be required through federal rulemaking, such as the mobility rule through the transportation legislation, can be derived directly from the HCM, making the HCM one of the only predictive methods that can actually predict reliability. While agencies are now routinely starting to quantify reliability based on existing conditions through probe data and speed and travel time data available, the ability to predict reliability for a new facility or to predict the impacts on reliability based on some sort of investment is something that's unique to the HCM. And so both the travel time distribution as well as the cumulative distribution of travel times is directly an output of the new HCM methodology. Turning to active traffic management, the HCM 6th edition, there's a typo there on the top of the slide, can evaluate the HCM 2010 was able to evaluate the ATDM effect on average travel times. Now in the 6th edition, we're able to quantify that reliability impact that I've mentioned before. Looking at the two charts at the bottom of the screen, even small changes in the average travel time may result in large improvements in the reliability, which can now be quantified as an extension to the reliability method. A few features specific to the freeway analysis now that have changed. The webinar hosted in December of this year will go into additional detail. There's a brand new freeway work zone method developed under NCHRP 3-107, new managed lane method that was developed in NCHRP 3-96, new truck method developed through the NCFRP program, project number 41, new guidance on ATDM evaluation through a federal highway project, new guidance on segmentation, and then a brand new planning level methodology for freeways that was developed as part of the Planning Preliminary Applications Guide through NCHRP 7-22. So many different research projects feeding into changes to the freeway methodology. A few structural changes. The previous chapters on basic freeway segments and multi-lane highway segments ended up being combined in this version of the HCM in a combined Chapter 12. And the motivation for that was, on the one hand, the two chapters had a lot of overlap and a lot of similarities, where the basic methods for basic freeway segments and multi-lane highways were quite similar, but there were some distinct differences between the two. And by integrating both in the same chapter, gave us the ability to more explicitly recognize those differences, talk about the differences in terms of access management on a freeway versus a multi-lane highway, and how that impacts the performance. But both methodologies are very similar, and that also freed up some pages for some of the additional material that was added. One of the key and probably the most exciting changes in the freeway method is a new formulation for the speed flow curve. The equation form is shown at the top of the screen, and there's much guidance in the HCM on how that equation is applied. The key take-home message here is that the results are not changing. This is a new equation form that was fitted to the prior speed-flow relationship that was available in the HCM 2010. So if you're doing a standard freeway analysis, HCM 2010 versus HCM 6th edition, the answers should not change. So why did we change the methodology? The reason was that really the key changes are in these capacity with subscript adjusted and free flow speed subscript adjusted, which are recognizing the need to calibrate the performance of freeways based on a whole number of different effects. One example could be a freeway work zone, as this one that's shown here in Southern California, without shoulders, narrow lanes, pretty poor pavement, and barrier walls. Another example could be that of a managed lane in the bottom left, or a hot lane facility. Top middle picture is a freeway merge area that acts as a bottleneck. Bottom middle is another work zone example out of Raleigh, North Carolina. And then on the right, there's a managed lane example. There's a variety of different factors that could influence either the free flow speed or the capacity. And the HCM 6th edition specifically recognizes the need for agencies to calibrate their freeway models to correctly replicate the congestion patterns. The ideal capacity of 2,400 passenger cars per hour per lane is limited to ideal conditions, a flat facility with proper lane widths, proper shoulders, and no other effects that may reduce capacity. But the reality is that especially many of our urban freeways do see congestion and see capacities significantly lower than 2,400. The HCM explicitly recognizes this, gives guidance for how those effects should be incorporated in the methodology, and even gives guidance for field estimating that capacity based on available sensor data. The managed lane methodology, material from NCHRP 3-96, has been integrated into the different chapters. Managed lanes on basic segments, on weaving segments, and on merge and diverge segments have all been integrated into the respective chapters to where a managed lane can now be evaluated either in isolation on an individual segment or integrated as part of a broader freeway facility. Other changes in the freeway multi-lane highways are new truck PCE tables based on the research done in NCFRP 41. I mentioned the increased emphasis on calibration and specific guidance for how to do that. The driver population factor, which was previously integrated as an adjustment to the volume, has now been modified to be handled as an adjustment to the capacity and the free flow speed, which makes more intuitive sense because unfamiliar drivers are more likely to drive slower or result in the overall reduction of the capacity as opposed to impacting the demand side of things. And then a few more changes for multi-lane highways, some clarifications based on previous inconsistencies that have really been brought forward by integrating this chapter and this methodology with the basic freeway segment. For the two-lane highways, the biggest change is that there's also a new work zone methodology that's available in Chapter 26. There's also some new guidance for how to apply the method. And really the biggest news is that there is a new method being developed as part of NCHRP project 17-65. That project is ongoing, has not been completed as part of the HCM 6th edition. So this is the first chapter that we anticipate being updated even after the release of the HCM 6th edition. And as Paul mentioned in his introduction, through the new structure, TRB will now be able to update individual chapters. So if you're interested in two-lane highways, keep a lookout on Project 17-65, and then a new chapter that will likely be released within the next few years as a new version number for that particular chapter without needing to update the entire HCM. Let me go through a few updates, key updates on the urban street side. Again, we will provide much more detail in future webinars. One change for urban street facilities is that the service measure, so that is the performance measure that defines level of service, has been modified to refer to just the average travel speed as opposed to the average travel speed as a percent of the free flow speed. So there's a modification there. Some changes to the level of service A-B threshold that were lower to the equivalent of an 80% free flow speed. So these are both changes that will impact the results. If you've done urban streets analysis in HCM 2010, these are some changes that will directly impact your results. Through the reliability methodology and the project that developed reliability methods, we now ran into a lot of scenarios for urban streets similar to freeways where spillback does occur. And because of that, there was a need to develop a methodology for evaluating spillback from one segment into the next, how that impacts the volume processed, how that impacts the signal timing. And so that method is now explicitly integrated into urban street facilities, which is quite exciting. To where now urban streets, just like freeway facilities, can handle oversaturated conditions and account for spillback. And some changes in the pedestrian bicycle level of service that are now weighted by the travel time on the segment as opposed to the segment length, taking into consideration that if travel speeds are low, if there's an upgrade, a bicycle, for example, may spend much more time in a particular segment, therefore impacting the weighting of that segment on the overall level of service for a trip, as opposed to weighting it just by length. Similar to the freeways, the reliability framework has been fully integrated into the urban street method. So Paul mentioned the two interim chapters, 36 and 37, as well as a chapter on ATDM, previous chapter 35 in HCM 2010. All that material has now been integrated directly into the core chapters for urban streets, resulting in a reliability calculation process that is very similar to that of freeways and uses that same concept that I had illustrated previously. Repetitive application of the core methodology with varying inputs that reflect changes in demand, capacity, work zone, signal timing, and so forth, similar to the guidance on ATDM strategy, which has also been integrated. Looking at the urban street segments, so this is the shorter piece of the urban street facility or arterial street from one intersection to the next. The service measure changes here have been changed consistent with the urban street facilities. There is a new methodology for evaluating segments with mid-segment blockage. So that resulted out of the work zone research and CHRP 3-107, where you could either have an intersection or a mid-segment work zone, and the effects of that have been integrated. Similarly, the procedure for predicting the queue spillback time and the impacts on vehicles processing through an intersection are explicitly incorporated, and also some new adjustment factors for parking activities that then has a direct influence on the free flow speed estimation. Further changes to urban streets through the completed roundabout corridor project and NCHRP 3-100. The procedure can now evaluate segments that have roundabouts at one or both ends of the facility, which is increasingly important as agencies are looking at both full roundabout corridors as well as corridors that have both roundabouts and signals, or roundabouts and alternative intersections, a roundabout next to an R-cut. So all these configurations are being considered. Some changes to the right turn on red vehicles, and that they are now incorporated in the volume balancing method. So as we are evaluating the arrival flow profile for intersection B on the right of the screen, we're now considering the fact that there are some right turn on red vehicles mid-segment as well as at the upstream intersection, and how that impacts the arrival patterns and therefore the delay and queuing patterns at the downstream intersection. Similar changes to the pedestrian bicycle level of service that are based on time-based weighting, and some changes to the default values for bicycle and buses. So many changes for the urban streets. Zooming further into the signalized intersections, so we went from the larger urban street facility to the shorter urban street segments, now to the individual intersection. We can now explicitly consider the delay of unsignalized movements at a signalized intersection. And that's important because there was a discrepancy in the HCM where the roundabout methodology included the effect of right turn bypass lane, so this is just a free-flowing lane, added all those vehicles with zero delay to then estimate the total delay at the approach of a roundabout, while at a signalized intersection that movement was fully excluded, and the signalized intersection only characterized or calculated the delay at the actual signal, taking out these free-flowing unsignalized movement. So in the desire to establish consistency across chapters and allow for a fair comparison between different intersection forms, roundabouts and signals, as well as some of the new alternative intersections that are now in the HCM, that user input has been added for signalized intersection. Through the work zone effort, we have new adjustments for the saturation flow rate, both for work zones at the intersection, for mid-segment work zones, as well as downstream blockage effect, as well as the new heavy vehicle adjustments and the PCE values, how they impact the saturation flow rate as an integrated function of grade. So that rather than separate factors for heavy vehicles and grades, it's now explicitly considering that heavy vehicle on an upgrade has a much larger effect than a heavy vehicle on a flat grade. Finally, on signalized intersection, the new planning method, similar to freeways, it is provided now in Chapter 31, also in the Planning and Preliminary Engineering Applications Guide. That planning level has a simple analysis worksheet and is literally a back-of-the-envelope pen and paper and calculator computation, just as the freeway methodology is. So the HCM has garnered some criticism with the HCM 2010 that methods have gotten increasingly complicated and more difficult, taking out some of the gut feeling and back-of-the-envelope character that previous versions of the HCM had. This is exactly what these new planning methods are intended to counteract. These have been developed from and calibrated through the full methodologies, but provide a quick estimation, planning level look at intersection performance, at freeway performance, and so forth. Looking at roundabouts, the biggest change that a lot of analysts have been waiting for is the new capacity models for roundabouts. And for those of you familiar with the HCM 2010 roundabout capacity curve, the intercept on the top right image used to be at about 1,130 vehicles. That intercept has increased significantly, meaning larger capacities for roundabouts in the U.S., more similar to what we have seen in other countries globally. This is based on extensive research that Federal Highway sponsored on roundabouts, and these results have been integrated now into the HCM. Similar to the calibration emphasis I mentioned on freeways, there is a calibration emphasis for roundabouts to clarify how the roundabout capacity can be calibrated for local conditions. And I mentioned previously the roundabouts also incorporated into both the segment and facility methodologies. And lastly then, a new chapter on ramp terminals and alternative intersections. The HCM 2010 had a chapter on interchange ramp terminals that allowed for the evaluation of diamond interchanges and SPUI single point interchanges, park close. Through, again, research sponsored by Federal Highway, that chapter has now been expanded to include a greater variety of what we call distributed intersections. So these are small intersection systems where you have two or more signals that work jointly to process traffic through a node. So an interchange is one example, but we also have many examples of at-grade intersection that fall into this category, and many of the alternative intersections, including the R-cut or super street, the displaced left turn, or also continuous flow intersection, fall into that category, and the HCM can now explicitly evaluate these in a planning level context. I know many agencies will go to simulation to look at the operation, to use the visualizations for public output, but the HCM can now give a direct comparison of these different intersection types and their impacts on the level of service without having to go to simulation. And so those new methodologies include the DDI, or diverging diamond interchange, with methodologies to look at both crossovers, including methodological details such as saturation flow rate adjustments, lane utilization adjustments, really specific operational characteristics of the DDIs that we hadn't previously seen, that are now integrated into the HCM. So I encourage you to take a look at those. The RCUT, restricted crossing U-turn, or also known as a super street in some states, that can be with signals. So there's a signalized RCUT here, or an unsignalized RCUT with just yield-controlled movement and a weaving, two-sided weaving maneuver to get to the U-turn base. The median U-turn, or Michigan left, as well as the displaced left turn or continuous flow intersection, both in the full and partial configuration, are now all integrated into the HCM. What ties all these together is a new service measure that is being introduced called experience travel time. And that really recognizes that a vehicle that, for example, in this case, makes a left turn from a minor street onto the major street at an RCUT, really has a series of maneuvers, starting with some control delay at point 2, some travel time between point 2 and 3 and 4, some potential control delay at point 4 to make the U-turn, and then additional travel time to leave the intersection area of influence at point 7. So the new procedure explicitly tallies all these different travel times and delays, and integrates all of them together into one service measure called experience travel time, and then derives a level of service based on that. So that leads me to just a few summary slides before we open it up for question. We see a lot of questions coming in, but please go ahead and add other questions as you think of them. Really, in terms of summary, there's a few key points that the research team, the Highway Capacity Committee, the Transportation Research Board really are emphasizing as we're looking at the new HCM. One, the HCM 6th edition is a more robust tool set than ever before. The research over the past 6, 7, 8 years has really targeted some of the traditional weak points of the HCM. Many of you on this webinar have likely been involved in the research in terms of reviewer and panel members, agencies that provided data. So really a large national effort that led into this, to where we now have specific methodologies to evaluate travel time reliability, managed lanes, the trucks, the work zones, the new roundabout methods, new performance measures. So really key gaps that have been filled in the HCM to provide a very robust tool set. These methods have also been research tested and validated, as well as peer-reviewed more than ever. Paul showed you a few of the examples for the sensitivity results and the example problems, the sample results, which are now available for all the different methodologies to really provide sensitivity testing to clarify what inputs are important, what inputs don't have as much of an impact, to really provide that explicit guidance, as well as a lot of input from agencies across the country. The HCM really supports a variety of applications. I mentioned and emphasized the back of the envelope methods that are in the PPEAG, the Planning and Preliminary Engineering Applications Guide, really pen, pencil, calculator methods that any analyst can use, that lend themselves ideally to teaching methods in a university environment, but really that are also available just for gut feeling and fact checks. Demystifying the HCM process from the black box application of software tools towards a real understanding on the side of the analyst. But then we also have a lot of the traffic analysis level ranging from really different, the high level planning to very detailed operational analysis, such as possible for freeway facilities, giving opportunities for performance monitoring, and then explicit guidance for what is the role of HCM in conjunction with simulation. The Highway Capacity Committee recognizes, of course, the availability of simulation, so the HCM makes an explicit effort to explain the role of HCM relative to simulation. The travel time reliability method that I mentioned really is one that cannot be practically performed, though, with simulation. Anyone who has used the simulation tool, who has struggled to calibrate just a single-day model for an average performance, the thought of repeating that calibration to reflect randomly generated incidents, weather, work zones, both planned and random, special events, the effort to do that in a fashion that repeats it 250 times in simulation environment is really not practically feasible. And so as we're moving towards a kind of a national framework where we're looking at mobility performance differently, where we're looking at reliability measures, the HCM really becomes the key predictive tool to quantify these performance measures with software already available today that agencies can apply. And finally, the HCM remains the key support for the modern practitioner. So there's the concept and guidance on how to apply the software, how to calibrate, how to interpret the results. Luckily, there are many software tools available that help us as analysts apply these methods. But the HCM is the agreed upon resource that sets the standards that we can turn to for questions and interpretations. There are computational engines available for free on Volume 4 for those that don't have access to software. And then really the applications guides that provide examples for how the HCM was applied to actual projects that are available for free in Volume 4, along with all the background and documentation. Any of the research reports that I've alluded to, NCHRP 3107, 396, all these numbers, you don't really have to remember most of these because they're all included in HCM Volume 4. So if you don't have your account yet, I encourage you to create one for free to have access to all these resources. That brings us to the end of the presentation. Thank you for listening. This was the first of a series of webinars with the remaining dates listed here and also advertised by ITE. And with that, we'll open it up for any questions. Thank you.
Great, thank you so much, Lily, Paul, and Bastian. So now we will open up the floor for our Q&A, and I will pull up the slide for that. All right. So the first question that we have, what is the empirical basis for pedestrian LOS standards? Can you provide references for studies upon which standards are based?
Okay, I'll take that one, Courtney. For first, it's probably good to point out that the Highway Capacity Manual itself doesn't set level of service standards. It presents thresholds for the different LOS letters, but it leaves it up to transportation agencies to decide whether they want to set a standard based on it, and if so, what that standard should be. But if we want to talk about what the basis is for the thresholds that appear in the manual, really there are two projects that, or sets of projects that develop them. The Florida DOT sponsored a project or a series of projects where people went out and actually walked or biked courses in different cities in Florida and rated the conditions of different segments based on a 6-point scale. Then a model was fit based on the characteristics of those different roadways to best come up with a model to predict how those different characteristics influenced people's perceptions of the quality of service. That was then expanded in NCHRP Project 3-70 to a national level where video labs were used to, in several parts of the country, to expose people to different conditions and have them rate how they felt the quality of service was. And then later in the project, there was a series of probably a dozen or so workshops where the method was tried out in different regions around the United States, both with MPOs, local cities, state DOT representatives. So that the latter part of that, the 3-70 project, is documented in an NCHRP report, which you can find on volume 4. If I remember, it's number 616. There's also a couple of NCHRP research results digests that go along with it that provide more details of the testing program. If you go to the NCHRP website for 3-70, you can find those documents. And then the FDOT research was by Bruce Landis and some other authors, and I believe it's referenced in the chapter, but not currently available on volume 4.
Great, thank you so much. The next question that we have is, the reliability analysis tools appear excitingly useful for reporting performance methods. Is the required data highly intensive to generate results?
Yeah, I'll take that question. The research effort leading into the reliability method, Sharp 2L08, tried to develop as many defaults as are possible to streamline this process. So the answer is yes, there are a lot of new data inputs that are needed for reliability analysis, but also the HCM contains a lot of defaults. For example, for the weather, we're looking for probabilities for different weather events, light rain, medium rain, heavy rain, snow, fog, by month of the year, which is clearly a very overwhelming input. As part of the research project, however, we did go to the roughly 100 largest airports in the country, extracted 10 years of historical weather data, and used that data to already develop those probabilities for you. So for the weather input, the input is as simple as going to a drop-down menu in whatever the software implementation is to select the largest metropolitan area close to your study area, and then generating the weather. Similar for incidents, the HCM recognizes some incident prediction methods, whether it's the HSM or the HERS model. There's a few different tools out there. If you don't have facility-specific incident data, although with incidents, of course, the more specific data you have, the more accurate your analysis is going to be. And that's also true for the demand variability. The HCM contains some defaults for demand variability by day of the week and month of the year. For example, Friday traffic may be different in many parts of the country than Tuesday through Thursday. And so the HCM provides some defaults, but that is one area where in some more recent testing, a lot of agencies have been testing the reliability method through the Reliability Implementation Assistance Program, or IAP. So a lot of agencies are testing the methods, are using them, and some of those test results were finding that especially the demand data as well as the incident data provides more accurate and better results if those are facility specific. So it's kind of a long way to answer the question. If you're just interested in getting an initial look at reliability, you can get there very quickly with built-in defaults in the HCM and the associated software. But then there's lots of opportunity to further calibrate things to the specific characteristics of your facility.
Great, thank you. The next question. Anything about collector distributors, specifically single lanes, being added in this version?
Yeah, I'll take that one as well. That's a good question. There's no specific reference of collector distributor systems yet, which is still a big limitation. The CD system could be evaluated as a standalone facility, and there is some guidance now on what the speed flow relationships on a single lane could be, and that comes from the managed lane data, where we have plenty of managed lane facilities that are a single lane. So there's some increased guidance, but there's no full integration, for example, of a congested CD system spilling back onto the main line. There's a new research project underway that actually Lily is the principal investigator for, NCHRP 17-57, I believe, which is developing new systems methods, systems analysis method for the HCM, which I believe will tackle some of these challenges. And so this would be another case where in the next few years we'd be looking for an interim update of those applicable HCM chapters to consider CD systems and spillback effects.
Great. The next question is, there seems to be a theme with the software-related questions, so I'll just read a couple of them. To start, will software now be developed by private companies using HCM 6 methods? I think you touched upon this a little bit. And then the other question, what software is available for analyzing signalized intersections using the HCM 6 methodology? And I know there's another one in here. Oh yeah, when will software updates come out for McTrans and for Synchro?
Okay. Yeah, so a whole series of questions there. So many software developers, let me try and answer this very generically, because we, as the committee or the research team, we don't really have control over what software developers do. But through the HCM development process, I know that many software developers, such as the one that were mentioned here, McTrans and Trafficware Synchro, and many others, PTV and TSS and other software vendors, have all followed the HCM update process very closely. Many of them have attended many of the committee meetings, and I believe many of them have been working on developing the software to where these tools will be available soon, if they're not available already, now that the HCM 6th edition is out. The committee does not endorse any particular software, as Paul mentioned, so it's up to the vendors to assure that they provide a faithful implementation of the methods. In some cases, there are some computational engines available through HCM Volume 4 that are non-supported software tools, software engines that were developed as part of developing the methodology. When we're talking about something like the reliability methodology for freeways, for example, that is clearly a very complicated method, and so in order to develop example problems, in order to test the method, to test its robustness, a software tool was developed called FreeVal that will be made available for free on Volume 4. However, as I mentioned, it is not a commercial supported software, and it is therefore one that maybe is an interim tool that people can use until commercial implementations are available.
Great, thank you. The next question that we have is adaptive traffic signal control addressed in the new HCM?
I guess I'll take that one as well. A lot of methodological questions. Adaptive signal control is not explicitly included. The HCM signalized intersection and urban street method has made significant advancements since earlier iterations, to where it explicitly considers and represents an actuated coordinated controller. It explicitly includes inputs such as splits and offsets. It includes a platoon dispersion model. It includes kind of an arrival flow prediction model that then drives a phase duration module. So it gets pretty complicated. But there's no specific guidance on how that would be implemented in an adaptive signal system. So that would be an area of a limitation for the HCM where, so again, the base condition could be evaluated, but an adaptive system likely would be something that is better evaluated in simulation.
Great, thank you. The next question, how much extra input data do we need to do reliability analysis?
So I think I answered most of that in an earlier question. You know, so I talked about the demand variability, the weather variability, the incident data, and any data on special events and work zones. And as well as the default values available for these. The one thing maybe to emphasize is that each chapter, including the reliability chapter, has very specific tables on the data input needs. So if you have questions on any chapter for what are the data inputs, Paul gave an example of one of those tables for two-lane highways, but every single methodological chapter has a table that clearly says these are the input needs, these are the data sources, these are the default values for that input, and then there is some formatting that gives guidance on whether that is an input that has a significant impact on the results versus not. So a lot of guidance on input needs, data sources, and so forth, including for the reliability.
Okay, thank you. Does the new version provide level of service for whole roundabout or just for approaches?
Yes, the new version provides level of service both for the intersection as a whole and for individual approaches.
Great. Does the new HCM incorporate a methodology to analyze a weave on an urban roadway, such as an arterial road versus a freeway segment?
Not at the moment.
Yeah, good question. Yeah,
but there is a funded NCHRP project that will be starting in the next fiscal year, I believe, to do just that. Just want to point out, put in a plug for state DOT members and FHWA staff who may be listening, that a lot of this research that goes into the manual comes out of research needs that states and the FHWA identify. If the research doesn't get funded, then it never makes its way into the HCM. And so arterial weaving is something that the committee has identified as a need for many years now. And a project has finally been funded to address that. So the HCM is pretty clear about what its limitations are. So if there are things from a state DOT perspective, FHWA perspective you'd like to see in there, certainly working through your organization to sponsor research is the way to get that information into future updates of the manual.
Great. We have a few more questions. Let's see. How does HCM 6 account for accessibility with an example?
Well, I think accessibility as one of the dimensions of mobility. That's the one dimension that really the HCM doesn't cover in any depth. There are other sources for other modes that look at, for example, transit accessibility, very important for the transit mode. And you could also look at roadways in terms of ADA accessibility, but accessibility in general we don't say is the dimension of mobility that really isn't a focus of the highway capacity manual. The other three dimensions are.
Great, thank you. And I just wanted to mention really quickly, I will be going over how to earn PDH credit again for attending today's webinar and instructions for hosts here momentarily as soon as we answer about 3 more questions. The next question that we have, I see the Highway Safety Manual is referenced and used by the HCM reliability methods. Is this an example of these 2 separate tools coming together in analysis?
I think that's a great question. I think it's the first step towards getting those two tools together. They have been, somewhat separate processes, separate guidebooks with different focus areas. I do think reliability is the first kind of hook to bring those two together, but I do think that this is still very much in its infancy. For most of the reliability work that I'm aware of, the inputs used actual crash data on a facility as opposed to predictive crash data, and so I think that there is a need for more applications and research on how exactly that tie can happen. I believe the pieces are there to where, for example, the HCM Highway Safety Manual has methods for predicting crash rates, incident rates, for widening, for taking away shoulders, for narrow lanes, which is a research project ongoing, and the HCM would have the ability to plug those revised crash estimates into the reliability analysis. So theoretically that connection can happen, but I don't know that it is very explicitly described how that happens. There's also a new, so the HSM2 project is ongoing, so that's also part of the development still in the HSM. So I would foresee that we will see more of that integration in the future. The pieces are there, but I think more work is needed to really specify and illustrate how that connection can be made. Great future research topic.
Yeah, I'd also like to point out that the HCM identifies a number of what it calls companion documents, recognizing that the HCM can't do everything for everybody, that its primary focus is on operations and quality of service, but that the Highway Safety Manual is important to turn to if you want to look at not only the operations impacts of a proposed mitigation measure, but what are the safety impacts of it. Then the HCM is a resource you can turn to. Other companion documents include FHWA's Traffic Analysis Toolbox series of reports, the Transit Capacity and Quality of Service Manual for detailed transit analysis, the METCD, and a couple of other documents as well.
Great. We have two more questions. I don't know if you have time to summarize these very briefly and answer for each of these. The first one, the new update has any information. Well, let me reword that. Does the new update have any information about sizing new arterial roadways with signals based on the daily volumes or peak hour volumes? So if you want to go ahead and answer that question, I'll ask the next question after you answer.
I think it's one of the potential applications. So the HCM now has the planning level methods and has also has service volume tables that could be is a very quick reference to look at, for example, with a certain ADT, what could be a target level of service as a function of different numbers of lanes. And also in the example problems, there are certainly different ways that an HCM method can be applied. It can be kind of a traditional, here's my facility, here's my demand, here's my capacity, what's the level of service. But the HCM methods can very much be applied to say, I have, this is my demand, here's my target level of service, how many lanes do I need? And there are example problems for that throughout the chapter.
Great. And can signal timing analysis be done for transit priority and signal preemption scenarios?
No, that answer would be similar to my answer for adaptive signals. It's a little bit beyond the realm of the HCM, better application and simulation.
Great. And Bastian or Paul, if you wouldn't mind sending me the link for the access to the online volume 4, I will type it into the chat pod for all of the attendees today who are still on the line, and a few other administrative type questions related to the Highway Capacity Manual I have are related to this webinar. The recordings will be available for all registrants registered attendees. 1 hour following this webinar, you'll receive an email with instructions for how to earn PDHs, as well as a link to the recording. And Volume 4, it sounds like, is free to use. I'll get that link from Bastian and Paul as soon as I can get that to you. And
it's hcmvolume4.org, so
okay,
pretty easy.
There you go. Perfect. HCM4.
Volume 4.
Oh, hcmvolume4.org. Okay. And then, has the 6th edition been printed already? Where can we purchase it? You can purchase that in either on TRB's website or ITE's website. And currently, they ran out really quickly, and they're reordering them. So I believe by mid to late November, those should be back in stock for ordering. Let's see. Sorry, one moment. Okay, and one last item. Yes, so how to earn PDH credit. So that concludes our Q&A period. So thank you, Paul and Bastian. To earn PDH credit, I went over this before the webinar began. You will need to write down each of these only one event code depending on what type of registrant you are. If you registered